Today's review video is solving fractional inequalities, or another name is called rational inequalities. It seems like a lot of people have a lot of problems with this because you skip one major step. And the step that you tend to skip is the very first step here, step number 1. You need to state the value or values for which the denominators would equal 0. You want to find out what would make the denominators what's called undefined. And the reason being is because you can't have that in an answer. And if it's an inequality and that's in that answer, it's going to screw everything up, because if the denominator is set equal to 0, you don't have a fraction anymore. It can't be solved. All right, so you need to do that first, and then you're going to solve as an equation. So you're going to pretend the inequality symbol's not there. You're going to use all the values you found in the first two steps to divide the number line into intervals, and then you have to test a number in each interval to see where your answers lie. All right. With that being said, let's go ahead and do this. First step, we need to state what would make any of those denominators undefined. Well, the only one that would be x minus 2, and the x would have to be a positive 2. So x equals 2, and I'm going to box them over here and leave them. Now I'm going to solve this like an equation. So I have x over 3 minus 1 over x minus 2 equals x plus 1 over 4. Because I have fractions equal to a fraction, I'm going to do what's called the LCD method. So I'm going to multiply everybody by the LCD to get rid of all those denominators. Let's see, the LCD for 3 and 4 would be 12, and then I'd have to use x minus 2 to get rid of him. So I'm going to use 12 times x minus 2. So this guy's going to get multiplied by 12 times x minus 2. This guy is going to get multiplied by 12 times x minus 2. And this guy is going to get multiplied by 12 times x minus 2. All right, let's see what I can cancel out here. I can cancel out, I can reduce 12 and 3, and this becomes a 4. So that denominator's gone. Let me erase that. Let me make that better. I don't think that you can see that that's an x minus 2 there. There we go. All right, here I can cancel out the x minus 2's, which is nice. And here I can reduce 4 and 12 and get a 3 here, but at least the denominator's gone. All right, so let's see what I have left over. 4 times x minus 2 times x. Well, let's multiply 4 times x first. That's 4x. And 4x times x minus 2 would be 4x squared minus 8x. Okay, that wasn't too bad. Minus 1 times 12, so it's a minus 12, equals 3 times x plus 1 times x minus 2. Oh, that'll give, I'm going to write this one out. I'm going to write this one out as 3x plus 3 times x minus 2. That's just too much for me to multiply in my head. So I'm going to bring down the left side. I'm going to do FOIL to the right side, first outer inner last combined like terms, and I'm going to get 3x squared minus 3x minus 6. Okay, that's a little easier. Oh, I have squarings on both sides. Let's move one side to the other. So I'm going to subtract a 3x squared on both sides. I'm going to add a 3x to both sides. And I'm going to add a 6 to both sides. So on the left, I'm going to have x squared minus 5x minus 6 equals 0. Okay, I'm going to see if I can factor in t-bar this. And I have, let's see, an x and an x, minus 6 and a plus 1. So I end up with x is 6 and x is a negative 1. Those are two more answers. So now I have 3 box guys that can go on my number line. Okay, so I'm going to put everybody on that number line. So I have a negative 1, I have a positive 2, and I have a positive 6. I go up and look at the original inequality symbol. It just said less than. There was no equal to symbol, so all of these guys are going to be open circles. Now I have to check somebody in each interval. So I would actually take negative 2, plug it into the original equality, and see if it worked. And it did work, so I'm going to put a yes there. So I'll put a Y. going to check someone in between -1 and 2, which would be 0. And I'm going to put an n there because it didn't work. Check somebody between 2 and 6. I'm going to choose 3. I plug 3 into the original inequality and see if it works. And I'm going to get another yes, it worked. Plug in somebody who's bigger than 6. Let's try 7. And again, I plugged it into the original and I got a no. So my answers will lie this way and in between here. So now I need to write my answers out. My answers can be x has to be less than -1, or x can be greater than 2 but less than 6. That is my answer for that inequality, because those are the only places that I got a yes. All right, let's take a look at another one. Number 4. Okay, first things first. What would make any of those denominators equal to 0? Well, the only thing that would make any of those denominators equal to 0 would be x equals 0. Box it in. He's going on the number line. All right, I'm going to rewrite this as an equation. So 5x plus 6 over 5x equals 2/3. All right, I need an LCD for x, 5x, and 3. Oh, we're going to use 15x. So I'm going to multiply this guy by 15x, this guy by 15x, and this guy by 15x. All right, let's see what I can cancel here. An x for an x. 5x goes into 15x 3 times. 3 goes into 15 5 times. So let's see what I have left over. 15 times 5 gives me 75. Plus 6 times 3 gives me 18. Equals 2 times 5 times x gives me 10x. All right, 75 and 18 is 93. 93 equals 10x. This is an easy solve. Divide by 10. 9.3 equals x. Okay, there's my, whoops, equals x, not 0. There's my second answer. So I only have 2 guys to put on a number line this time. I go back up and look at the inequality. The inequality symbol didn't say an equal to, so I'm just going to have open circles at 0 and 9.3. I need to test numbers that fall bigger than 0, a number between 0 and 9.3, and a number greater than 9.3 to see what works. Well, when I did the test for anybody less than 0, I ended up with a no. In between 0 and 9.3, I used 1, and it worked out. And again, you're testing into the original inequality. And greater than 9.3, I got a no. So, open circles, because no equal to symbol, and they connect. So the only inequality answer I have for this, x has to be greater than 0, but less than 9.3. That one was pretty easy. All right, let's go on to our last one for today. Let's see. What would make this denominator undefined? Well, the only thing that would make it undefined would be -4. So x equals -4, and I'm going to box it in because he's going on the number line. All right, I'm going to write this as an equation. X squared minus, let me make that better. Okay, x squared minus 2x minus 8 over x plus 4 equals 0. All right, the LCD is going to be x plus 4, because that's the only thing I've got as a denominator. All right, they're going to cancel here, and I'll end up with x squared minus 2x minus 8. Anything times 0 is 0. That was pretty easy. I'm going to go right to 2 binomials. I get an x and an x, factors of a -8, that'll give me a -2, minus 4, plus 2, t-bar. I get x equals 4, x equals a -2. All right, so now I have 2 more guys that get to join the number line. Here we go. I'm going to have a -4. The smallest guy comes first. Then I'm going to have a -2. And then I'm going to have a +4. Look at the inequality symbol. It said equal to. The only one, though, that I can actually fill in is the -2 and the +4. And the reason being is, if I say equal to -4, it's going to make it undefined, and we can't have that. It just helps me to have a starting point. So now I have to try a number in each interval. And I tried, I think, a -5, and then I tried a -3, and then I tried 0, and I tried 5. And let me tell you what I got. I ended up with a no here, a yes here, a no here, and a yes here. So now, which means these guys connect, and this goes this way. So now I'm ready to write my answer. I can have every x that is greater than -4, can't say equal to, and less than or equal to -2 because of the closed circle, or I can have every x that is greater than or equal to +4. There are my answers for that rational inequality. I know there's a lot of steps to this because you're actually talking about undefined, and then you're using the LCD method to get rid of denominators, and then we're using the number line and plugging a lot of choices into our inequality, our original one, to see what works and what doesn't. But you really need to know this, especially if you are taking the Algebra 2 trig exam. Please review this video as many times as you need to, and hopefully it will help.